Okay, today we're going over 3.6. Is the last section in this chapter is the rational functions. Rational functions. So what is the meaning of rational function? Before we study the rational equations, today we're going over the rational functions. So the rational function here is a function, any function of the form r of x equal q of x over b of x. What is q of x and b of x? They are polynomials. So here I can set is a polynomial function over a polynomial function. So polynomial function over a polynomial function is called the rational function. Okay. First of all, we have to know the function g of q of x and the other function b of x. Both of them are polynomial, such that it does not have common factor. There is no common factor between q of x and b of x. And the second things we have to know, the graph for r of x is not look like the polynomial function. As we learned before, the polynomial function has like graphs like that, or like this, or have something like this, up, down, whatever. But r of x does not have graph look like these things, okay? So we're going to learn in this section the domain and the range of the rational function and the asymptote. So first part of this section is the domain and range and asymptote. Okay, first of all, what is the domain of the rational function? So the domain here, I can define the domain of the rational function is always R, is always the real numbers. So when I ask what's the domain for rational function, anything like this is real numbers, except we have to remove the zeros for the denominator. We have to remove the zeros of the polynomial function in the denominator. So is all real numbers except the zeros for the denominator. So let me give you an example. And during this example, I will show you the rational function and the domain, the range, and how we can graph the rational function. So example, let me do the example in the second slide. Graph the rational function f of x equal 1 over x. So this is a rational function, polynomial over polynomial. So the question is graph this function and find the domain for this function and find the range and the range. So first of all, to graph this function, we're going to use the plot point by using the table. So let me make a table. So we're going to learn how to graph this function by a table. Then we're going to learn it by using the transformation. We're going to do a transformation for this function. So this is the table here. Now let me take like random numbers. I'm going to start from -2. Here is x. Here's f of x equal 1 over x. As we learned before, we pick up any points, we plug inside the function, we represent it in the xy coordinate. So let me here graph the Cartesian plane. This is my Cartesian plane. So let me pick the numbers as like from -2, -1, -1/2, 0, 1/2, 1, and 2. To make it closer to each other. So I'm going to make like complete the table. So here is because I need more space. 1, 2. Let me check now. Here's, for example, -2, -1, -1/2, 0. So I need to have now 1/2, 1, and 2. So here 0, 1/2, 1, 2. Okay, what is the value for minus 2 after I plug it inside the equation? What is the value for minus 2? Minus 1/2. Yeah, that's true. When I plug the minus 2 inside this one, I get minus 1/2. For minus 1, what I get after I plug it inside this equation? I get minus 1. That's true. What about minus 1/2 when I plug it here?
Minus 2.
Minus 2. How I find it? Let me show you. So when I plug here minus half, actually I get 1 over minus 1/2. And by using chapter 1, this is equal 1 times the reciprocal for this one. The reciprocal for this one is minus 2. 1 times minus 2 is minus 2. That's why I get here minus 2. Okay? What about the 0? Undefined. I cannot find the value. So here undefined. No values. What about 1/2? 1/2 again, when I plug it here, I get also again what?
2.
2. What about 1? Is 1. What about 2? Is 1/2. So let me represent this point in the Cartesian plane. At 0 is undefined. No value at 0. No value at 0. At 1/2, they give me 2. So let me put this is like 1/2. Here 1. There's 2. There's 3. No, it's not like, let me change it. So this is my 1/2, for example. This is 1. This is 2. There's 3. There's 4. So at 1/2, they give me 2. The value is 2, 1, 2. So the value around here. At 1 is give me 1. So at 1, like around here. But I want to explain more things. Let me like make it more bigger. Here. So I make it, this is like my 1/2. This is 1. This is 2 here. And this is 3. So here 1/2, 1, 2. And here like around 3. Here. So at 1/2 they give me 2, like around here. At 1 they give me 1. At 2 they give me half, like around here. At 3, when I plug the 3, they give me 1/3. Like number close to the 0, like around here. So I see here when I go down, like the numbers become bigger and bigger. As you see here. When the number become bigger and bigger, like 4, 5, 6, 7, 8, up to infinity, this number goes down to the 0, become like close to the 0, 1/3, 1/4, 1/5, 1/6, until I arrive like the number is so close to the 0. Does make sense? And the same things here. Let me plug the negatives and I will show you. So here minus 1/2 and minus 2. So minus 1/2 like around here, and minus 2 like around, like something like around here. Minus 1 and minus 1. This is my minus 1 and minus 1 here. Like this. Minus 2 and minus half, like around point, like around here. And the same things, minus 3, they give me minus 1 over 3. So as I see here, when the number goes down, like more smaller to minus infinity, like minus 4, minus 5, minus 6, minus 7, this number becomes close to the 0, as you see in the line. So the graph here, it will be like something like this, like that, then goes like this. And here, become more closer to the 0. And here the same things, more closer to the x-axis, then become like more bigger, up to here. But what's happened to the values here in this area? Like more smaller than 1/2.
You're dividing by a smaller and smaller number. So
Smaller and smaller numbers.
You're gonna get a bigger and bigger.
Bigger and bigger. So when I like divide by small and small, the numbers become like bigger and bigger, close to the y-axis, but does not touch this axis. Like be more closer to this, but does not touch it. I mean, like if I pick up any points here f of x, let me make another table. So let me make a small table for the values between 0 and 1/2. Like if I pick up values like 0.1, when I plug the 0.1 inside this one, they give me what? This actually 1 over 10. When I plug 1 over 10 in this one, they give me 10. Same things if I plug 1, 0.0. It's like around 1 over 100. When I plug 1 over 100 in this one, give me 100. So look, again, smaller and smaller become bigger and bigger. 1, 0, 0, 0. This is 1 over 1000. Give me 1000 here. So as I see here, when the numbers become smaller, like close to the 0, this numbers goes up to infinity, become bigger. So this value here is 1.0, 10, same thing, 0.01, 100, and here 1000. 1, 0, 0.0. So this interval, I can represent it here, continue to this one, or like will be like more closer to the y-axis, but does not touch the y-axis. So the graph actually would be look like this. Is more closer to the y-axis, but does not touch it. Sorry. And the same things for the negative side here. Be closer to the y-axis, but does not touch it. So actually the graph, if I want to represent it clear, will be like this. Like that. From here, the x-axis, when you go into infinity, will be close to the x-axis, but does not touch it. The same things from this side. If I go up, it will be close to the y-axis, but also in the same time does not touch it, will not touch this axis. So how I know this value become closer to the 0? I pick up any numbers again, x and f of x. I take the negative 0.1, they give me negative 10. Same things here, negative 0.01. They give me here 10, 100, and so on. When the number goes to like to 0, here the numbers goes to infinity. Okay, it makes sense. What's the graph for what is the graph for 1 over x? So the graph for 1 over x, it's gonna be look like this. How we know? By using the plotting points. At 0 is undefined because look, when I plug the 0 undefined, but be like close to the interval. Now the question is, what's the domain? So what is the domain? As we look into the graph, the domain will be like everything except the 0. As we learn, all the values for x are used, but at 0 it doesn't used. And all the numbers here are used, but the value only this one does not used. So my domain will be like everything here used, everything used, but at 0 is open, it's not used, and again used, everything used. This is my domain. And the range, the same things. We're looking for the y-axis. Which value are used in the y-axis? So everything used. Everything are used here also. But at the 0 does not use again, because look, the y is not used. And the same things here. So can I set the domain? So the domain is the x such that x not equal 0. This means everything except the 0. Or if I want to represent it as an interval, I can set from minus infinity to 0 open interval, union from 0 to infinity. The range, the same things exactly, is y such that y not equal 0, or from minus infinity to 0, union 0 to infinity. So this is the range and the domain for this function. Any questions so far? The last things we have to know, the last things for this graph, we have to know, as x goes to infinity, as x goes to infinity, f of x here goes to 0. As x goes to infinity, f of x goes to 0, become more smaller. Same things here. As x goes to minus infinity, f of x goes to 0. For here, as f of x goes to infinity, become more larger, x, the value for x, become close to the 0, but positive. Positive means close to the 0 from right side. 0 here, the positive, means close to the 0, the value for x close to the 0 from right side. And the same things here, when f of x goes to minus infinity, x goes to 0 from the left side, negative. From this side, bx close to the 0. Makes sense? Any question? So here I can say it when x goes to infinity, so f of x goes to 0. As x goes to minus infinity, so f of x goes to 0 again. This is the first things. Second things we have to know, as f of x goes to infinity, so x goes to 0 from the positive side. As f of x goes to minus infinity, so x will be close to the 0 from the left side. Okay, makes sense? Any question for this? Anyone has a question? Okay, if there is no question, now let's go to the transformation. So now transformation by using the function 1 over x. So after, like right now, the graph for 1 over x gonna be something like this. Something like that. What is the domain? Everything except the 0. What's the range? Everything except the 0. And we have to know when the function be like larger, the function they give me value small to the 0, close to the 0. Same things from this side. Same things here, when the function goes to infinity, the x value will be close to the 0 on the positive. Transformation now. So now we're going to graph the function, any function, by using the transformation without using the table and the plotting point. So any rational function of the form r of x equal ax plus b over cx plus d, I can graph it by shifting, stretching, reflecting. For the graph of x equal 1 over x can be graphed by shifting or doing stretching, or I can reflect it by using the graph f of x equal 1 over x. So f of x equal 1 over x, I can use it like my original function to graph any rational function. Let me give example how we can use this function to graph any rational function. Example, graph a graph and find the domain and range by using f of x equal 1 over x for number a function r of x equal 2 over x minus 3. B s of x equal 3x plus 5 over x plus 2. So who will give me the idea how can I graph this function by using this function? I know the graph for the original function f of x equal 1 over x. The graph for this function is look like this. Like I graph it in the beginning. Something like this. So how can I use this graph to graph this one? Without table, no, we're going to use the transformation. Angel, we don't have to use the table, we're going to use the transformation. So let me do this one and I will let you do the second one. So to do the first one, r of x equal 2 times 2 over x minus 3. First of all, we have to try to change, we have to factor this function, first of all. So to factor this one, I get r of x equal 2 times 1 over x minus 3. The goal is to make the numerator here equal 1. This is the important things. I'm trying to make this one equal 1. This is the important things. Here I have to get 1. Now, to using this function, f of x equal 1 over x. If I plug inside this function, instead of x, here, instead of x as the value 1 over x minus 3, I will get a new function like this, f of 1 over x minus 3 equal 1 over x minus 3. So now, these things, I can represent it instead of these things here. So I'm going to use these things instead of these things. So this r of x equal right now 2 times f of 1 over x minus 3. Do we work as a quadratic function? No. We have, look, for this function, we have to try to make this function r of x equal something times f of x. Now, when we do this, I can graph the function r of x. So to graph this function by using the transformation, I know what does that mean. So the minus 3, it's inside the function, and we multiply by 2. What is the mean of 1 over x minus 3? That 1 over x minus 3, we have to shift the function 3 units to the right. And the 2 here means we have to stretch the function vertically. Why stretch vertically? Because the 2 is outside the function. So to graph this function is the same as graphing this function. It makes sense? Okay, let me explain them again. So the question is, graph the function r of x equal 1 over, 2 times 2 over x minus 3. Now, by using the function f of x equal 1 over x, this is my function. Now, I have to change of this function such that I have to make it like equal something of this function. First of all, I have to factor this one because I need the numerator equal 1. This is the important things. So to factor this one, this is give me, by factoring, r of x equal 2 times 1 over x minus 3. This is the first step. Now I have to make this function, I have 1 over x. I have to put the f inside this function. Why? Because they will make me easy to graph this function. So I know the function f of x equal 1 over x. Now if I plug instead of x minus 3, plug here x minus 3, I will get another function f of x minus 3 equal 1 over this things, x minus 3. This here, inside the parentheses, is the same as 1 over minus x3. I can put instead of this f of x minus 3. So this is equal actually 2 times, here inside the parentheses is the same like this one, because 1 over x minus 3 is the same f of x minus 3. Here I make a small mistake. This is wrong. Forget this one. So f of x minus 3 is the same as 1 over x minus 3. Now, instead of these things, I put this one, f of x minus 3. So now r of x is equal to times f of x minus 3. Now I know how to graph f of x. The graph of the function f of x is something like this. This is f of x. Equal 1 over x, as we graph it in the first slide, like this. This is f of x equal 1 over x. Now, f of x minus 3 means we have to shift this graph 3 units to the right. Okay? So after we shift this graph 3 units to the right, this is my asymptote, the vertical asymptote. So this point here, this, we have to shift it 3 units to the right, is 0. So here 1, 2, 3. It's become here. So this line become like here, and this line become here. So this is my new line, like around this. This is my new line here. Everything here shifted to this side. So the new graph look like this. Okay. This was the mean of shifting. Shifting everything 3 units. The y value does not change. We'll shift everything to the right. It means the line here, this line, we shifted the 3 units. 1, 2, 3 become here, and this axis, it will stay at the same things. Does not change anything. Now everything here will be shifted into this box. Everything here will be shifted to this box.
Does it, Professor, does it get somehow like steeper because there's a 2 in front of that's 2 times f?
Yes, after that, this is the second step. Now the third step, we have to multiply by 3, by 2. So this is here. This is number 1. We draw a graph f of x equal 1 over x. This is number 2. Number 3, you have to multiply by 2. When we multiply by 2, this is mean we do stretching for the function. So stretching for the function, I will graph the stretching here in the same graph. By the way, this is my y-axis, the original axis. This is my x-axis. My asymptote, this is called the horizontal asymptote, by the way. This is called the horizontal asymptote. Horizontal asymptote. And this is the vertical one. So my vertical asymptote become this line. And this is my horizontal asymptote. This has become my horizontal and this is my vertical asymptote. Now we have to multiply by 2. This is the function here. I graph here the function f of x minus 3. Just I shift everything to the right 3 units. Now I have to multiply by 2. This is mean I have to do stretching vertically for this graph. So I mean vertically, every point will be like I have to stretch this graph vertically up and down. I'll show you in the third graph. Up to here is fine. Angel, is it clear? Anyone has a question from the first and second graph? Okay, let me do it fast, what I did here. First of all, I have to go to write down the r of x equal this. I have to factor it because I have to need here in the numerator 1. Must be 1. Now, I have 2 times 1 over x minus 3. I know the function f of x equal 1 over x. I have to plug inside x instead of x minus 3 because when I plug x minus 3, they give me the function f of x minus 3 equal 1 over x minus 3. And 1 over x minus 3 is the same like this one inside the parentheses. This is what I need. So r of x equal 2 times f of x minus 3. Now I know the graph for f of x 1 over x. This here, this means the original graph, we have to shift it 3 units to the right. This is my horizontal line. This is my vertical asymptote, horizontal asymptote. This point here, the 0, 0, this point, I have to shift to 3 points. 1, 2, like around here. This is my new point. And again, this is my vertical asymptote. This is my horizontal asymptote. the graph here will be shift everything from this box to this box, from here, this quarter to this quarter, and again from this one to this one. This is like from this one to this one. This point here is 3. I have to write it down. It's 3. And this point is 0. 1, 2. Now the third step is stretching. So my new line now is stretching. Means stretching, vertically stretching, by using chapter 2.6, up and down. The graph will be like around something like this. Like the point goes up, all the points stretching up like this. And here again, the same things. This is the final, this is the r of x equal 2 times f of x minus 3. This is the graph of my function. Anyone has a question? This is my horizontal vertical asymptote. This is x equal 3 because this point is 3. This is my horizontal asymptote. Horizontal asymptote. The equation for this one, y equals 0. This is x equals 0. This is y equals 0. And this is the graph of my function. Anyone has a question? Any question, like any confusing things? I can like explain more if you have a confusion something. It is clear.
Yeah, that makes sense.
Okay. For the second one, the same exact idea. But here we have to make how you multiply by 2. How you multiply? Because here I factor it. R of x equals 2 over x minus 3. I factor it. So I put the 2 outside. For the graph, this is mean like the 2 outside, this is mean like by section 2.6 is stretching vertically. Stretching vertically, like everything goes up. Like the values goes up. Or like, well, he said all the value you have, all the y value have to multiply by 2. Exactly. Like this value is 1, for example, here. If this value, for example, 4 and 1, this is 4 and 1, right? This one become 4 and 2. Like here, 4 and 2. This point is 2. Like all the value multiply by 2. 5 and something become like multiplying by 2. Because the original one here is 4 and 1, become 4 and 2. And the same things for all values. We stretch it up. Make sense, Awang, Jim? Like we have to stretch it, like we have to, all the points goes up, like 4 and 1, again 4 and 2, for example, the 5 and half become like 5 and 1 here, like here around 1 maybe. And the same things, we have to stretch all points up. It's not shifting, it's stretching. It's not the same like shift. Shift, we have to move all the points up, but here is different. Shifting and stretching is different. For the second one, I'm going to give you the hint, but I'm not going to graph it. I'm going to give you like how we can graph it. I give you like the idea how to can do this function similar to this function. How can put the function f inside the function. So for B, the question is s of x equal 3x plus 5 over x plus 2. To do this, we have to do like the long division by using the previous slide, previous section. 3x, we have to divide 3x plus 5 by x plus 2. So dividing 3x plus 5 over x plus 2, here I get, by using the long division, here I have to put 3 times this one, I get 3x plus 2. I change the sign because here we have positive become negative, they become negative. This cancel each other. Now 5 minus 2, they give me 3. Here's 6, sorry, 3 times 2 is 6, not 2. I make a mistake here, here's 6. 5 minus 6 is minus 1. So minus 1. So actually, 3x plus 5 over x plus 2 is equal 3 minus 1 over x plus 2. This is from the previous section. So s of x, now I can set is equal 3 minus 1 over x plus 2. S of x is the same like this one, and this one equal to this one. Now the same idea like before. How to make the f of x inside this function? I know f of x equal 1 over x. If I plug inside, instead of x, this value x plus 2, because here we have 1, is good. X plus 2, I will get f of x plus 2 equal 1 over x plus 2. So now this things is the same like these things. So this is mean s of x is equal 3 minus f of x plus 2. Now to graph this function s of x, I have to graph this one. 3 minus the function f of x plus 2. To graph this function, I have to graph this function. Let me give you the hint what I did here. So I know how to graph the function f of x. This means here, graphing the function, then we shift it to the left 2 units because we have plus 2. Then we have to multiply by 2. This is mean we have to reflect it around the x-axis. Then we have to shift it up 3 units because 3, we have 3 here. Make sense? I'm not going to graph it. I'm giving you just the hint how to graph it. Again, I know how to graph the function f of x equal 1 over x. Here, we have to shift it 2 units to the left. Then we have multiplication. This means we have to reflect the function around the x-axis. Then we have to shift all the function 3 units up because we have 3 here, positive 3. Any question? Is it clear, this example? Like, do you have any question or are you confusing for something? I can explain it more. Here in this function, I do the long division, and the long division they equal 3 minus 1 over x minus plus 2. Then I change s of x instead of this by this function. Now this one, 1 over x plus 2, I can change it or I can replace it by the function f of x. I know the function f of x equal 1 over x. If I plug x plus 2, I get f of x plus 2 equal 1 over x plus 2. This things is equal f of x plus 2. So actually s of x equal 3 minus f of x plus 2. Now to graph this one, we have to shift this function, the original function of x equal 1 over x, 2 units to the left, reflect it around the x-axis because we have minus, then we shift it 3 units up. Any question? Is it clear? Okay, I think no questions. I hope everything is fine and clear. So now let's go to the new chapter, chapter 4, 4.1. Is the exponential function. The exponential function. So this chapter talk about the exponential function is different about chapter 3. Exponential function. So what is the exponential function? Have you heard about this one before? Exponential function?
Yeah.
What is it? Like, what is the meaning of exponential function?
Is it something to the power of x?
Yes, exactly. This is an exponential function, like something to the power of x or of any variable. So I'm going to define it. So the exponential function with base, this function has a base a, is the function f of x equal a to the power x. What is x? X is a real number. X is a real number, any real number. What's the value for a? A must be greater than 0. And at the same time, a not equal 1. Why a not equal 1? Why a not equal 1 here?
1 to any power is just 1.
Is 1. Like f of x equal 1 over to any power. Infinity, 1, 0, whatever, it will be like 1. And f of x equal 1 is a constant function. The graph for this one is horizontal line such that y equal 1. At this point, 1 crossing the y-axis. That's why here a not equal 1. Because if a equal 1 will not be exponential function, will be constant function. So this is the definition of the exponential function. Any function of this form, R here is real numbers. A is any number greater than 1, than 0, and a not equal 1. Okay, let me give you example for exponential function, like for example, f of x equal 2 to the power x, or f of x equal 7 to the power x. This is exponential function. This is exponential function. The 2 here is the base. The 7 is the base. It's called base. First things we have in this section, we're going to graph any exponential function. So graphing of exponential So to graph the exponential function, we're going to start by using plotting points. Then after we graph by using the plotting point, we're going to use the transformation. So I'm going to do this one by example. Explain that by example. Graph the function by plotting point. Of f of x equal 3 to the x, b g of x equal 1 over x, 1 over 3 to the x. So I'm going to use table for these things. After we're going to use the table, we're going to use the transformation. Okay, let me starting doing the table. So I'm going to do both of them in the same table. So A is for f of x equal 3 to the x, and for B is g of x equal 1 over x, 1 over 3 to the x. So the table like this. Okay. So I'm going to use the values here x, here f of x equal 3 to the x, here g of x equal 1 over 3, 1 over 3, everything to x. What does that equal actually? I want to make it the fraction instead of fraction, something like this, without a fraction. What does that equal? This is from chapter 1. 1 over 3, everything to the x. What does that equal? Without a fraction. Anyone? What does that equal? So again, this one here, this, anyway, would you like to answer? What does that equal here? What's your answer? Yeah.
Like turn it into like a negative exponent.
What is the answer?
3 to the negative first power.
Yes.
Or
This is the answer. Yeah. So the answer is, like using the chapter 1, if I want to remove the fraction, I go this up, it will be like 3 to the negative 1, everything to the x. And this is equal 3 to the, we can multiply the minus 1 with the x, negative x. So this one and this one are the same, but the different are the exponent. The exponent here positive, the exponent here negative. Again, this is my email. Don't forget to email me. So now let me pick any points. Like for example, I'm going to take minus 3, minus 2, minus 1, 0, 1, 2, and 3. 3 points. Now I have to plug this point inside this function and also inside this function. I start from the 0. 3 to the 0 is
1.
1. 3 to the 0 is 1. And also 3 to the 0 here in this function in g of x is
Also
again
1.
Again 1. Yes. So the one here, okay. Now, for the second points, for the 1, 3 to the 1 is 3. 3 to the 2 is 3 squared is 9. 3 to the 3 is
27.
27. What about the minus 1? 3 to the minus 1 is
1 over 3.
1 over 3. 3 to the minus 2.
1 over 9.
1 over 9. 3 to the minus 3.
1 over 27.
27. Here the same things. 3 to the minus 1. 3 to the minus 1. 3 to the minus 1 is
3.
3. 9 again. 27. Here the vice versa. 1 over 3. 1 over 9. 1 over 27. To represent this point, I have to choose different colors here. Here, let me make this is by the blue, and the other one is by the red. 1 over 1. Let me do it fast. Here f of x equal 3 to the x, 1 over 27, 1 over 9, 1 over 3, 1, 3, 9, 27. So for the blue color is the function f of x. The first point is 0 and 1. This is 0 and 1. 1 and 3. This is 1. And here is like around 3. For the 2, 2 and 9. So this is 2. Like the 9 around here. For the 3 is 27. So the 3 here. 27 like up, like around here. So the graph will be something like this. Like this. So this is the graph for the function f of x equal 3 to the x. For the red one is vice versa. Everything everything reflecting around the y-axis. So 0 and 1, again 0 and 1. Here. So here 0 and 1, here is 0 and 1. 1 and 1 over 3, this is 1 and this is over 3. 2 and 1 over 9, like around here. 3 and 1 over like close to the 0. So the graph would be something. And the same things for the other sides, minus 1 and 3. This is minus 1 and 3, like around here. Same things, minus 2 and 9, minus 2 and 9, like around here. And again, the last point around here. So the graph will be something like this. So the graph will be like something like this. Here. Like this. And here, up like that. So again, this is the red one. So the function, this one is the g of x equal minus, like not minus, 3 to the minus x. So look, the both function are the same, but the blue one is the same like the red one, but both of them reflecting around the y-axis. So both of them are reflecting around the y-axis. So the both functions are the same, but they are reflecting around this axis. So the function f of x equal 3x to the x and the other function 3 to the minus x are the same, but both of them are reflecting around the y-axis. So when the minus is up as exponent, this means we have to reflect the function around the y-axis. Any questions so far? So again, let me show you something before I give you the quiz, before the quiz start. The quiz start at 30:35. We have 10 minutes more. So the first things we have to know the domain here. What's the domain?
All real numbers?
All the numbers. So the domain is the real numbers. What's the range?
In this case, it's just greater than 0. All numbers greater than 0.
Anything greater than 0. And the 0 is not inside the parentheses. So 0 to infinity. So the domain all real numbers. Why? Because look to the x-axis. If I want to use it for only the curve, the red curve or the blue curve, I'm going to use the blue curve. The f of x equal 3x to the power x. So the domain is all the values for the x-axis are used. This means the domain is the real numbers. And for the range, starting from the 0, because the curves be like close to the y-axis but will not touch the y-axis. So open circle here, and everything are used here. Everything used, this is mean the range is from the 0, and the 0 is not inside the interval to infinity. So the range is from 0 to infinity, and the domain is all the x-axis. What is the asymptote here? What is the what's the line asymptote? So the asymptote here is showing in the graph, it's the y-axis, this one, y equals 0. For the both curve, for the curve, the blue curve, it's the y equals 0. For the red curve is y equals 0. So this is my asymptote. The function will be like close to the line, but will not touch it. This is mean what the asymptote. The curve will be close to the line, but will not touch it at all. This is mean this is the y. This is the asymptote. So here the asymptote, the horizontal asymptote is y equals 0. So we have to know the domain, the range, the y asymptote, the horizontal asymptote. This is the most important things. Okay, so now after we see the graph for 3 of x and 3 of the minus x, I can give you example. I can explain more things. The graph for any exponent function is gonna be something like this. Any exponent function in the life, the graph, it has to be something like this. Always something like this. It passes this point. 0 and 1, and will be something like this. When this function will be something like that, only this is f of x equal a to the x such that any number greater than 1. Any number greater than 1 the graph will be something like that. So can here set f of x equal a to the x such that a is greater than 1. Like 1, 2, no, not 1, 2, 3, 4, 5, 6, whatever. Always the graph will be something like this. This is the x-axis. And this is the y-axis. But the graph here at the point again is 1. And again, the graph will be something like that. Always like this. For f of x equal a to the x when a between 0 and 1. Zero and 1, f of x will be something like this. The graph for any function will be something like that. If a is greater than 1, if a between 0 and 1, the graph will be something like this. Always, no different graphs. This is the only two graphs for any exponential function. Okay? So next time I'm going to give example and I will continue for this section. Thank you and get ready for the quiz.